Number one, in this experiment, you will investigate the oscillations of a pendulum. Set up the apparatus of shown in figure 1.1. These are the apparatus set in this experiment. The length L of the pendulum is distance between the bottom of the wooden blocks and the center of the adhesive body. Adjust the length of the string so that L is approximately 53 centimeters. Measure and record L. So L equal 53 centimeters, 53.0. Use the second boss to attach the wooden rod to the stand. Adjust the apparatus until the vertical string of the pendulum just touches against the wooden rod, as shown in figure 1.2. That's the apparatus. Okay. The distance between the bottom of the wooden blocks and the center of the wooden rod is S. Adjust the positions of the wooden rod so that S is approximately 36 centimeters. Measure and record S. I have measured and record S is 36 centimeters. Calculate L minus S. L minus S, it means 53 minus 36, it equals 17. So 17 centimeters. Move the adhesive body a small distance so that the string moves away from the wooden rod. Release the adhesive body. The string hits the rod as the pendulum oscillates. Take measurements to determine the period T of the oscillations. Right. So T of the oscillations is 1.5. On my experiments, T equal 1.5 second. Okay. So next, change S in the range, this interval, the X interval, as greater than or equal 5, less than or equal 45 centimeters. By adjusting the positions for the wooden rod, determine T, repeat until you have 6 sets of the values of S and T. Record your values in a table, includes value of square root L minus S in your table, right? So I'm going to create a table. Okay, you may use your ruler. Okay. The first column is L, unit centimeters. Second column S, unit centimeters. The third column L minus S, centimeters. The third column is square root of L minus S, centimeters, the unit. And the last column is T, unit is second. L is 53. And S, I have set 36, 38, 40, 42, 44, 46. L minus X a 17, 15, 13, 11, 9, and 7. Okay. Square root 17, 4.1, 2.9, 3.6, 3.3, 3, and 2.6. T, based on my experiments, are 1.5, second, 1.3, 1.1, 1.0, 0.8, and 0.6. This is my table. Plot a graph of t on the y-axis against square root L minus S on the x-axis. Draw the straight line of best fit. Determine the gradient and y-intercept of this line. Okay. This is the graph I would like to create. Wait, yeah, this one. Okay. I would like to create the graph around here. Okay. You may use your ruler for this. This is axis for square root L minus S. It means this unit is centimeters, while this axis, the vertically axis unit S is for the for t-axis, right? And according to the table that we are going to find this coordinate point, 4.1 and 1.5, 3.9 and 1.3, 3.6 and 1.1, 3.3 and 1.0, 3 and 0.8, 2.6 and 0.6. And the intercept point on y-axis is this one, square root L minus S is if uh, if square root L minus S is 0, so t as well equal 0. So the intercept point on y-axis is on the origin. This is the origin. Right. Firstly, 4.1. 1, 2, 3, this is 4. 4.1 this line, and 4.1 and 1.5. This is 1. Okay, 1.5 this line. Okay, and this. This is the coordinate point of 4.1 and 1.5. And afterwards, 3.9 and 1.3. 3.9 this, 3.9 and 1.3 here. And then 3.6 and 1.1. 3.6 is 1, 1.1 here. And the next 3.3 and 1. 3.3 and 1 here. 1 or 0.9. I prefer 0.9. And then 3 and 0.8 or 0.7. I prefer 0.7. Here 0.7 and 0.5 and 0.6, 0.5, 2.6 and 0.5, 2.6 and 0.5. 6 or 0.5. So if you sketch, it will be straight line like this, but the intercept point here, the intercept point around like this, maybe like this. If you sketch the straight line, so the straight line is the intercept point, the coordinate point, y-intercept is 0 and 0. How about gradient? I'm going to determine gradient to a coordinate point 4.1, sorry, 4.1 and 1.5, y over x. So gradient m equal 1.5 over 4.1. Okay, and if you calculate this is 3. So the gradient is 3. And the intercept point occurs when the intercept point, the intercept point, sorry, intercept point occur when square root L minus S equals 0. If this is 0, it means T as well equal 0. It's suggested that the quantities T, L, and S are related by the equation. This is the equation where A and B are constants. Using your answer in part D3, determine the values of A and B, give appropriate units. Right. So according to this equation that T equal A square root L minus S plus B. So at point, at point 4.1 and 1.5, is this is square root L minus S, this one T, right? So we can substitute into this equation becomes 1.5 equal A multiply 4.1 plus B. Or we can rearrange becomes 4.1A plus B equal 1.5. And at point 3.9 and 1.3, this equation becomes 1.3 equal A times 3.9 plus B. It becomes 3.9A plus B. It equals 1.3. Now, if minus it becomes 0, and then this is 0.2 equal 0.2. Right. We have eliminated P. Now we are going to determine A. A equal 0.2 over 0.2. It is 1. Now substitute A equal 1 into this equation. So 4.1 multiply 1 plus B equal 1.5. So B 1.5 minus 4.1 minus 2.65. So this is minus 2.65 and A equal 1. Theory suggests that A equal pi over square root g, where g is the accelerations of free fall. Use your answer in part E.1 to determine a value for g. Give an appropriate unit. Okay, so A equal pi over square root g. If we are going to determine g, and if g is the subject, we can rearrange this formula becomes square root g equal pi over a, or g equal square root equal pi over a squared. Okay, it's going to be 3.14 squared over a is 1. A is 1 according to our result here. A is 1. Okay. 1, okay, centimeters, power minus half. Sorry. I mean 1 centimeters second. This is the unit. And it's going to be, if you calculate, this is 9.8 over centimeters second, like that. Okay. Actually, this is becomes minus 1 because minus half times 2 minus 1, and it becomes 9.8 centimeters s power minus 2, or 9.8 centimeters over second squared, 0.8, like that. Number 2, in this experiment, you will investigate a wooden strip resting at an angle. You are provided with a wooden strip. This is the wooden strip, and shown in figure 2.1. The dimensions of the strip are x, y, and z. Measure and record x, y, and z. I have measuring, and my measurement are 50 centimeters, or 50 centimeters, or 0.5 meters. Y is 30 centimeters, or 0.3 meters. Z 20 centimeters, or 0.2 meters. The volume V of the strip is given by the equation. Calculate V, right? So V equal 0.5, 0.3 times 0.2. And if you calculate, the result is 0.03 meter cubed. Specify the number of significant figures that you have given for your value of V. The number is 0.03. 0 are not the significant figure only 3, so there is sorry, so there is one significant figure, and that is 3. Set up the apparatus as shown in figure 2.2. This is the apparatus already set. Adjust the positions of the boss so that the road or the climb is approximately 0.3 meters above the bends. Okay, like this, 0.3, the climb. Use some of the adhesive putty to secure the 30 centimeters ruler to the bends, as shown in figure 2.2. Already said, the raised end of the wooden strip is R, as shown in figure 2.2. Place the wooden strip on the rod and adjust the positions of the stand so that the distance between the rod and R is approximately 5 centimeters. This one. Use adhesive putty to attach the mesh to the wooden strip so that the distance D between the lower end of the wooden strip and the center of the mesh is approximately 0.15 meters, as shown in figure 2.3. So, measure and record D. Of course, D is 0.15 meters. Use adhesive putty to attach the loop of string at the wrist and R of the wooden strip, as shown in figure 2.4. This figure, okay, I have set my experiment. Use the Newton meter to determine the vertical force needed to just lift the wooden strip from the road. And according to my experiment, F equals 0.5 Newton. Estimate the percentage uncertainty in your value of F so you're working. My Newton meter percentage uncertainty is 0.05. So absolute uncertainty on Newton meters is 0.05. And the percentage uncertainty is delta F over F multiply 100%, and it's equal 0.05 over 0.5, this number, multiply 100%. And if you calculate, the result is 2.5%. So this is, sorry, not 10%. Sorry, 2.5. This is 10%. So 10% here. Right. Let's continue. Adjust the positions of the mesh so that D is approximately 0.30 meters. Measure and record D and F. So D is 0.3, while F is 2 newtons, according to the Newton meters. Right. It is suggested the relationship between Fx and D is the equation Fx equal Wd plus K, where W is the weight of the mass and has the value of 0.49 Newton, and K is a constant. Using your data, calculate two values of K. Right. The first K or K1 occurs when F equals 0.5 and D equals 0.151. So it means K1 equal 0.5 multiply X is 0.5 meters minus 0.49 multiply 0.15. And if you calculate, the result is 0.1765. Unit is Newton meters. The second K occurs when this one, when F equals 2 and D equals 0.30. So it's going to be 2 multiply 0.5 minus 0.49 multiply 0.3. And if you calculate, the result is 0.853 Newton meters. So the first value of K is 0.1765 Newton meters. This is 0.853 Newton meters, right? It is suggested that the percentage uncertainty in the value of K is 15%. Using this uncertainty, explain whether your results support the relationship in C. Right. I'm going to show you the percentage difference, the percentage difference between between K1 and K2, first K and second K. This the percentage is 0. According to the values of K1 and K2, 0.1765 over 2, multiply 100%, and the result is 131.5%. If you compare this result, and this is 15%, the given uncertainty, 15%. So percentage, the percentage difference is greater than the given uncertainty. The given uncertainty. This one, 15%. So it leads to a consistent conclusion that conclusion that the result not support not support the relationship. One. Next. Theory suggests that K equal rho times G Vx half, where G is 9.8 Newton per kilograms and rho is the density of the wood. Use your second values of K and values from A part 1 to determine rho given an appropriate unit. All right. So if rho is the subject, we can rearrange this formula being rho equal to K over G phi x. Yeah, so, right. So it means rho equal to multiply the second value of K, 0.853 Newton meters, K over G is 9.8 Newton per kg, and then after that volume is 0.03 meter cube, okay, and then after that, okay, multiply x. X is distance between the road and the strip, that is 0.03, 0.05, I mean 0.05 meters, okay. So if you calculate this, 2 multiply 0.853 over 9.8 multiply 0.03, multiply 0.05. You can find the result is 116.72. How about the unit? Newton divided by Newton, okay, and then meters divided by meters, but kilograms would be this one, okay. So this is the unit. So the result, rho is 116.72 kilograms per meter cube. That's the result. F, describe four sources of uncertainty or limitations of the procedure for this experiment. For any uncertainties in measurement that you describe, you should state the quantity being measured and a reason for the uncertainty. First, I have provided my explanation, my briefly explanation. The readings are insufficient to draw a a valid conclusion. Second, y is small. It implies to percentage uncertainty is large. The third, difficult to maintain the Newton meter at vertically position. And the fourth, difficult to measure D with a reason due to difficult to make sure the center of mass. Part 2, describe 4 improvements that could be made to this experiment. You may suggest the use of other apparatus or different procedures. The first, take more readings for different values of D and plot a graph. The second, improve method to measure Y. Can use micrometer or calipers. The third, improve method to measure D, such as measure to the edge of the mesh and add on the radius of the mesh. And the fourth, improve method to ensure vertically use, for example, use a clamp meter rule and a set square to ensure vertical or use a plumb line as a reference.